let's review this review. It is the percents mid-chapter, check number 2, review worksheet. Now, we started this in class. One of the classes got almost all the way through it, but the other class didn't get very far. And there were, of course, some absences, so I'm going to review everything. Go ahead and skip past number 1 and 2 that we covered in class if you already got it. Number 1, what is the formula for percent error? Formula for percent error is percent error equals the absolute value of the actual value minus the estimate divided by the actual value times 100. That's it. That's the formula. So if we know the percent error, we would put it here. If we know the actual values, we'd put them here and here. We know the estimate, we'd put it there. And the times 100 would translate this decimal into a percent. Number 2. Bria brought cupcakes into school for her birthday. She thought that there were 50 7th grade students, so she brought 50 cupcakes. There were actually 48 7th grade students. What is the percent error? So she thought there were 50. That's her estimate. There were actually 48. That's the actual. And we want to know what the percent error is. So percent error equals the actual. We said actual was 48 minus the estimate. We said that she estimated 50 divided by the actual times 100. So 48 minus 50 is negative 2. Put that in absolute values, divided by 50 times 100. Absolute value of negative 2 is 2. Oh, whoops. I got ahead of myself. What should be on the bottom here? Actual, the actual value. And the actual value is 48. So 48 should be in the denominator. Sorry about that. 48. So, let's recap why I said that. It's actual minus estimate divided by actual. The actual number is 48, so that should belong here and on the bottom. And the estimate is 50, so that's what should be subtracted. And then that actual stays here, and it stays here. Now, we can simplify this fraction, or we can cross simplify here. Either way, and then I'm going to simplify by multiplying. So let's simplify this first. 2 and 48 are both divisible by 2. So we can go ahead and divide them by 2. 2 divided by 2 is 1. 48 divided by 2 is 24. So we have 1 over 24 times 100. Now we can just multiply and divide, or we can also simplify a little bit farther. If we simplify a little bit farther, we can realize that both of these are divisible by 4. We can divide them both by 4. So let's go ahead and multiply them first. 1 times 100 is 100. So we have 100 over 24. They're both divisible by 4, so we can divide them both by 4. Divided by 4, divided by 4. We get 25 divided by 6. Can we simplify farther? No. So now we can divide 25 divided by 6. 6 multiplies in 4 times. 6 times 4 is 24. So we can subtract 24. We're left with a remainder of 1. So we need to bring down a 0. 6 goes into 10 one time. We can subtract 6. We get 4. That's a remainder, so we need to bring down a 0. 6 multiplies into 40 6 times. We can subtract 36, and we're left with 4. Still, we got a remainder, so we can bring down another 0. It's getting really behind. It's kind of laggy now. 6 goes into 40 6 times. We can subtract 36 again, but we notice a pattern. There's a 40, and we keep multiplying into it 6 times. So we can stop and say that this 6 is repeating. So 4.16 repeating. So 4.16 repeating. Now, this is our percent error, so we're going to include a percent sign after this. So it's 4.16%. 4.16 repeating percent. That is our percent error. Alright, that is number 2. Let's look at number 3. Number 3, Mr. McCartney gave his students a quiz on Thursday. He estimated that 21 students would get an A on the quiz. His estimate was 50% off from the actual number of students. What are the possible number of students that earned an A? That's a lot. So they're taking a quiz. He estimated 21 students would get an A. So his estimate is 21 students. His estimate was 50% off. So that means the percent error is 50%. We want to know what are the possible number of students that earned an A. So the actual, we don't know yet. Don't know the actual. Remember, we still have our equation, right? We have percent error is equal to the absolute value of the actual minus the estimate divided by the actual times 100. Okay. Now, percent error we know is 50. We want to write this right as a percent, because this is the percent error. So we're going to keep this as a percent here. If this was just the percent value in a normal equation, like the percent equation, we would need to make it a decimal. But this actually is the percent error, and we are going to multiply by 100. So this is actually going to be the percent value. So this is going to be 50% is equal to the absolute value of the actual minus 21, our estimate, divided by our actual times 100. Now, this is a question that got a lot of people stuck, so this is a question that probably would not appear on the test for a whole lot of points. If it would be on the test, it would be for less points than normal, I think, or it would be for bonus. I don't think I'd put this on the test for normal points. That's right now. We'll see later on. But as of right now, it's causing a lot of confusion. So we're just going to go over it, and then we should know how to do it. But it's not going to be something that I'll probably test you on. So let's try to get A by itself. We want to figure out what that actual value is. So the first thing we're going to do is we're going to divide this side of the equation by 100. And when we divide that side, we need to divide this side. Okay, so 100 divided by 100, these cancel out. It becomes 1. And 50 divided by 100 is 0.5. So we have 0.5 equals the absolute value of A minus 21 divided by A. So this is what we're left with. We want to get A by excuse me. We want to get A by itself, so we're going to multiply this side by A because we have division by A and we want to undo that. So we're going to multiply by A, and we're going to multiply this side by A. Now, this expression times a divided by a divided by a would be 1, so we can cancel these out, and it leaves a 1. This side, a times 0.5, we have 0.5a equals the absolute value of a minus 21. Now, when we have absolute values, we know that the answer can be, or what is inside of the absolute values can either be positive or it can be negative. So, if we take a look at an example, the absolute value of x equals 4. What can fit in here that would make this true? The absolute value of 4 equals 4. Absolute value of 4 is just 4, and that's 4. Absolute value of negative 4 also equals 4. Absolute value of negative 4 is 4, and that's equal to 4. So either a positive number in here or a negative number in here, that gives us the same result. So just like that, we're going to do the same thing over here. We have absolute value of a minus 21 equals 0.5. So we can say that 0.5 a equals a minus 21. And we can also say that 0.5a equals negative a minus 21. So positive version, the negative version. Now, we want to get a by itself still, so what we can do is subtract a from this side to the other side, and we can, in this case, we can distribute this negative sign, and then we can add a. So let's distribute first. This negative sign is going to be multiplied to both of them. This is really negative 1. So this becomes 0.5a equals negative a plus negative times a negative, 21. Now we can add a to both sides. Add a here. Going to add a here. And we get 1.5a equals 21. We can solve, we can divide both sides by 1.5. And we get a equals 1.5 is really 3 halves, right? So we can change this to 21 over 3 halves. And we know how to solve that. We would do 21. Let's use a different marker. It's really 21 divided by 3 halves. You guys know how to do that. We would multiply, we would keep change flip, keep the numerator, multiply by this flipped. So 21 times 2/3, and that becomes 14. Let's go ahead and go back to the other side. Let's solve this one. 0.5a equals a minus 21. So what we can do is subtract a from both sides. Because it's a positive a, we subtract it. A minus a is 0, so we're left with negative 21 on the right side. The left side, 0.5a minus a, so 0.5 minus 1 is negative 0.5. So we have negative 0.5a. We can divide by this number in front of a, which is negative 0.5. Accidentally erased that. Let's go ahead and redraw that. It's getting a little sloppy, but bear with me. I don't know why it's lagging so bad. Maybe we'll change the format after this question. 0.5a divided by 0.5. We're Going to divide by negative 0.5 on this side as well. Okay, so now we get A equals negative 21 divided by negative 0.5, or negative 1/2. Again, we can change it just like we did here to 21 divided by 1/2. And then we can keep change flip, and we end up with positive 42. So our two possible actual values are 42 and 14. And now we can think about that in respect to this question. Remember, the question was that Mr. McCartney estimated 21 students would get an A. His estimate was 50% off. So 50% off of the actual value. So let's look at the actual value of 42. 50% of 42, or half of 42, is 21. So that's 50% off. The other option is 14. What if our actual answer was 14? There were only 14 students that got an A. What is half of 14? What is 50% of 14? Half of 14 is 7. So if we add 7 to this value, we get 21. So if we subtract half of 42, we get to 21. If we add half of 14, we get to 21. So these are the two possible answers that with a 50% error would give us 21. All right. Okay, let's continue with number 4. Got a new platform, so hopefully this changes it up a little bit. What is 27% as a decimal? 27% as a decimal. 27% as a decimal. Well, when we are changing percents to decimals, all we're going to do is move the decimal point twice. So let's rewrite 27%. 27 is a whole number, so the decimal belongs after the 7. If we move the decimal twice, then it would become a decimal. Now, when we're going percents to decimal, we're going to move the decimal from where it's at to the left. So we're going to go left twice. That's going to be our new point. So our decimal is 0.27. If we're going from decimal to percent, then we would go the other way. We're going to do that in the next problem. Number 5. What is 1.06? Oops. 1.065 as a percent? .065, let's rewrite it. 1.065. We're going to a percent. So we're going to move the decimal twice to the right. 1, 2. That's going to be the new spot. So we're going to rewrite it. 106.5%. Make sure we include the sign. And that's our answer. Number 6. Let's go ahead and scroll down. We want to calculate the total of a purchase of $30 with a sales tax of 15%. So our total purchase is $30. Our sales tax is 15%. Now, whenever we have a tax, a rate, we're going to change it to a decimal. So again, remember, percent to decimal, we're going to move the decimal point twice. So here's the decimal point. We're going to move it twice. So our decimal is going to be 0.15. So we have our price, we have our tax rate. We're going to multiply this price times the tax rate, and we're going to add it back to this price. So let's do that. $30 times 0.15, and we're going to add it back to our original price. So let's multiply 30.00 times 0.15. 5 times 0 is 0. 5 times 0 is 0. 5 times 0 is 0. 5 times 3 is 15. Let's write in our placeholder 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 3 is 3. So let's add these together. We have 0, 0, 0. 5 plus 0 is 5. 3 plus 1 is 4. Now, when we are doing decimal multiplication, we're going to count how many places are after the decimal. So here we have 2 in this first number. We also have 2 numbers after the decimal place in the second number. So the total number of decimal places is 4. So that means our places in our answer after the decimal should be 4. 1, 2, 3, 4. That's where our point should be. So the tax rate, this number is 4.50. So now we can add this together in our next step, right? We can go ahead and simplify this. This is 4.50 plus $30. And again, we get our answer. So 30 plus 4.5, we can write that out if we can't do that mental math. So 30 plus 450, add the zeros, add 5 and 0, 0 and 4, add 3, we have $34.50. And that is how we get our total. Right. Let's move on. Number 7. Number 7, your bill at a restaurant is $20 with a tip of 20%. And tax is 7%. What is your total bill? So we want to take this tip, we want to write it as a decimal. Again, we're going to move the decimal twice to the left. 1, 2, we get 0.20. We're going to take the decimal, move it twice to the left with this one. So we've got 7. Move it once, twice. I'm going to add in our placeholder 0. So this is 0.07. Now, we're going to multiply each of these times the original and then add it all together. So we've got 20 times 0.20. What I explained in class, and I'll explain now, is we can rewrite this to help us solve this a little bit quicker. So let's do 0.20 times 20. We're going to leave our whole number 0 at the end, and we're just going to bring that down here. Now we can multiply as normal. 2 times 0 is 0. 2 times 2 is 4. 2 times 0 is 0. Let's count the places after the decimal. It's 1, 2. So places after the decimal would be 1, 2. Here's our decimal point. It's $4 is our tip. Our tax is 7%, so we're going to do the same thing. We're going to do 0.07 times 20. Going to bring down the 0. 2 times 7 is 14. 2 times 0 is 0. Add the 1. 2 times 0 is 0. Count the numbers after the decimal. 1, 2. And do the same with our answer. 1, 2. There's our decimal point. So our tax is $1.40. Our tip is $4. Now we can add these all together. We can add the original price, the tip, and the tax. Original price, the tip, and the tax. So 20 plus 4 plus $1.40. Can add the cents, 0 and 4, and add the single digit dollars, 0, 4, 1, give us 5, 2 would be 2. So our total is $25.40. That would be our bill plus the tip plus the tax. Number 8. Number 8. Number 8 says a blank is a small amount of money in return for a service. A blank is a small amount of money in return for a service. That would be tip. A tip is a small amount of money in return for a service. Number 9. Number 9. What number is 24% of 50? 24% of 50. Now when we're talking about percents of something, when we're using this kind of language, usually whatever follows of is the whole number, and the percent is going to be the percent of that number. If we have is in our writing, usually whatever number belongs to is or is around is the part. So we have of, the number after it is our whole number, and percent as a decimal is we move the decimal point twice to the left. So the percent is here, the decimal is here, we're going to move it twice to the left, so we're going to have 0.24 as our percent. If we're following the equation to write the percent of a number, that equation is A equals PW, where A is the part, P is the percent, and W is the whole. So our part we don't know, that's what we're looking for. Our percent is 0.24, and our whole number is 50. So we need to multiply 0.24 times 50. We can do that, 0.24 times, we're going to use the same trick we did before. I'm going to leave that whole number 0 out to the side, just bring it down. 5 times 4 is 20, write the 0, carry the 2. 5 times 2 is 10, add the 2. Oops. Five times 0 is 0, add the 1. I got ahead of myself. How many numbers are after the decimal point? 1, 2. So we're going to do the same for our answer. 1, 2. So our decimal point belongs here. So 24% of 50 is 12. Not sure why it's struggling to give me more page, but let's maybe just add another page then. Okay, number 10. Number 10. 20 is what percent of 45? We see this keyword of, so this must be our whole number. What percent? So we don't know the percent, that'll be our p-value, and 20 would be our part, so that would be our A, our part. Now in our equation, part equals percent times whole. We have the part and the whole, we don't have the percent, so we can plug those in. A is 20, P we don't know, and W is our whole number. In order to get P by itself, figure out what the percent is, we can divide both sides by 45. 20 divided by 45 is what we're going to figure out. 45 divided by 45 is 1, so we're left with P. So our percent is 20 over 45. Okay, so now we can do this division. We can first reduce. We can divide both the top and bottom by 5, and we get 4 over 9. Now we can divide. This will be a little bit simpler. So we can divide 4 by 9. 9 does not go into 4. So we need to add a placeholder 0. 9 goes into 40. How many times? 4 times. We can subtract 36 and we get 4. Need to bring down another placeholder 0. We can subtract another 36. So it goes in 4 times. We get a remainder of 4. This is going to be repeating. So this is going to be 0.4 repeating. So our percent is 0.4 repeating. If we write this as a percent with a percent sign, we need to move this decimal place. We need to move it twice to the right. 1, 2. Now normally, when we move a decimal point twice to the right, we would fill this in with a 0, this extra place here. But since this is 0.4 repeating, this is actually going to be a 4. So this is going to be 44.44%, or 44.4 repeating percent. We need to make sure we include this repeating because otherwise we would lose the value in our percent. Okay, alright. Next one is number 11 and then 12. Number 11. $15 is 25% of what number? So 15 is 25% of what number? $15 is, so this must be our part, 25%, that's going to be our percent, of what number? We don't know what our whole number is. So that we're going to leave as a W. So if A equals P times W, we know A is 15. Our percent is written there. We need to write it as a decimal, so we're going to move the decimal twice to the left, and we get 0.25. We're multiplying by W, except we don't know what W is yet, so we're going to leave it as a variable. We want to figure out W, so we're going to divide this side by 0.25. We're going to do the same on the other side, divide by 0.25. 15 divided by 0.25. We can make this easier on ourselves. We can say that this is 15 divided by 1/4, because we know that 0.25 is really 1/4 as a fraction. So if we do 15 divided by 1/4, we do keep change flip, keep the numerator, change division to multiplication. Flip the denominator, so it's 4 over 1. 15 times 4 is 60. So 60 over 1 equals 60. So that would be our W. Our whole number is 60. So 15 is 25% of 60. Got one more question. Our last question is number 12. This is, what is 3/4 as a percent? 3/4. 3/4 as a percent. Now what we can do is divide. We can divide 3 divided by 4, and we can get our percent. It goes in 0 times. We add a 0 here, 4 goes into 30. 7 times, we subtract 28 and get 2, and we'll end up with 0.75 as our decimal equivalent. We can also know this as 3/4 in a dollar. So if we divide a dollar by 4, that's 25 cents each. That's 4/4. 3 of them would be 75 cents. And if we write this as a percent, we need to move the decimal twice to the right. So 1, 2. So this becomes 75%.